Vedant, am I audible?
Yes, Vaishnavi.
Thank you. When should we start?
We'll start in 2 minutes. Like, we'll wait for a few participants. If they have joined and on YouTube there are 18, we'll just wait for 2 minutes and then we'll start. Yeah.
Okay, okay.
I think Vaishnavi, we should start. Yeah, we'll begin.
Okay, Vedant. A very good afternoon to one and all present here. I, Vaishnavi, welcome you today to the second day with the second session of 2D and 3D modeling of STAAD Pro workshop. It's a privilege to have with us Mr. R. Udayashankar. I welcome you, sir, on the behalf of AISSMS College of Engineering. With no more delay, I ask you, sir, to take over. Thank you.
Thank you, ma'am. Good afternoon to one and all. Yesterday we'll discuss about how to create the 2D frame and how to apply the different loads and others, etc. Today we'll discuss about the little part of bending moment and shear force. Anybody know what is meant by bending moment and shear force? Already studied in your subject, the bending moment and shear force. The based on the reinforcement detailing is based on your bending moment. Okay, I will draw some. Okay, for simply supported beam, assume as a this is a simply supported beam. Simply supported beams fail in anyone? The simply supported beams fail in tension or compression. The moment will be high in tension or compression. Anyone? In simply supported beam. Moment high in tension zone. Okay, this is our tension zone for simply supported beam. This is a compression for our beam. Okay, this is a method. This is our longitudinal section for our simply supported beam. This is our cross section for our simply supported beam. Okay, this is the longitudinal section. This is the cross section for the simply supported beam. Assume as a simply supported, this is a moment. Okay, this moment is assumed as a 50 kN per meter. this moment. Okay, assume as this moment. This compression zone, you provide the reinforcement or not? You need the rebar or not in 10th compression zone? Anyone? The tension zone only simply supported means the tension zone only the moment will be comes. There is a moment. So the tension zone only moment. The compression zone, no moment. The moment is zero. So not needed for rebars for tense compression zone. Then you provide the tension zone. Compulsory provide the tension zone. Why? The moment will be high in tension zone. So provide the tension zone for this moment. Okay, this is a basic condition. You're providing for the reinforcement detail for simply supported to provide the higher number of rebars in bottom zone. So the simply supported, the moment is high in bottom zone. The compression zone, no moment. So simply provided the hanger bars. You design some formula is there at IS code M equal to 0.87 Fi into 1 minus AST. What is in by MU? MU is the bending moment. Okay, this is the moment. This value taken to apply this. You calculated the AST value. Understand? AST value, small AST divided by capital AST. You calculate the number of bars. Okay. For assumption, this is our cross section. This is our compression zone. This is our tension zone for cross section. The maximum reward provided in compression zone or tension zone. Anyone? The maximum rebars reinforcement provided in compression zone or tension zone in simply support beam. Anyone? The maximum rebars. The maximum rebars provided in tension zone only. Why? The moment will be high in tension. So your maximum rebar provided in tension zone. This I provide the rebar for assumption. I provided the 4 numbers of 16 dia. But I provide the compression bars, compression number 2 bars of 2 bars of hanger bars. Understand? I only provided the 2 bars of hanger bars. This is the difference. Why I provided the bottom zone for 4 numbers of bars? The 4 numbers of bars, the moment is high in tension. So I provided the 4 numbers of bars. The compression is only I provided the 2 numbers of hanger bars. Why? No moment in compression. That is a condition for you providing the beam. This is for simply supported. Continuous fixed end, calculate the moments. Continuous fixed end. Yeah, this is our fixed end, right? This is our fixed end. 1, 2, 3, 4. How to acting on the moment in this continuous fixed end supports? Simply supported, okay. One is the compression zone, tension zone. You provided for the tension zone only reinforcement. Compression zone will be 0. That is the concept. You see the sum of the building, the column will be smaller, right? Column size will be smaller, the beam size will be higher. Sometimes it's residential building or any industrial building, sometimes the column size will be smaller, the beam size will be higher. So it's a simply supported beam. The simply supported beam, beams do not travel to columns, only circulate to beams only. That is the basic condition. I understand. The simply supported beams, the beams do not travel to columns. So your column will be minimum size. The beam will be higher size. Why? That is a condition. Understand? Your moment not travel to column in simply supported beam. That is a condition. But continuous fixed end support, the moment transfer to columns. That is a condition. That's the 2 conditions are there. This is the simply supported continuous fixed end. See this. This is the moment type of your beams. Okay. This is a moment condition or your for continuous fixed end. Understand? Simply supported means only this type, tension zone only. But you go for continuous fixed end. The moments comes under this is a compression zone, this is a tension zone, this is a compression zone also. I take this beam only. Okay. I go for another. I take this beam only. Okay, sorry, this beam. I take the separate this beam. This is a fixed end. The moment will be this one. This is a single beam. This is a moment. This is the compression zone. This is the tension zone. This is the compression zone. But you go for simply supported, the cross section will take only one cross section. But you go for fixed beam, how many cross section will be taken? Anyone? How many cross section? That is our simply supported beam. Simply supported. Only tension zone, only moment. This is our cross section. Take only one cross section. But the continuous fixed end, it's a compression zone also moment will become, tension zone also came, and this end also came. Sometimes you design for residential building, you take the 2 or 3 cross section. Maximum you take the 2 cross section. The first cross section for this end, this is a AA, our cross section, and the next is a mid span. This is a BB for cross section. It is for CC for my cross section. See this is the main concept for your beam detailing. This is a continuous fixed end. The moment will be high in compression, tension also compression. I take the cross section in 3 A, B, C. Okay. I draw the 3 cross sections for this beam. This is a AA, this is a BB, this is a CC. Okay. Then how to provide the rebar details for this AA cross section? How to provide? Anyone? The bottom zone or top zone will be reinforcement will become higher reinforcement in compression zone or tension zone. Tension zone in AA. Anyone? The reinforcement will be high in compression or tension. This cross section. The moment will be high in compression zone, right? So the moment will be high in compression zone. This is a moment high in compression zone. Tension zone, it's 0. So you provided the rebar in compression zone. I provided the 3 rebars for my compression zone. I provided the 2 minimum rebars. Minimum only I provide for tension zone. Why I provide the 2 minimum rebars? Why? Simple. Simply no moment is there. So I refer the IS 456. The formula is there. I will show. Only 2 rebars I will be provided. That is the condition. And then go for BB section. That is a BB cross section. This higher rebars comes under tension zone. This is a tension zone. This is a moment will be high in tension zone. The compression zone is 0 moment. Then I provided the compression zone for minimum 2 bars. Then I provided the higher bars in tension zone for mid section in continuous support. Okay. The next cross section is CC. This bar higher from compression zone or tension zone. The rebars is higher in. Anyone? The rebars is higher in tension zone or compression zone. Compression zone. Why? The moment will be high in compression zone. So I provided this 4 bars. Okay. Then I tension zone, I provided this minimum 2 bars. That is the condition for taking the cross section. You go for simply supported beam, you take a only one cross section. You go for continuous fixed in residential building, compulsory you take a 2 cross section for the single beam. Why the beam will be taken into compression zone beam moment becomes and tension zone will be moment will become. So you take the moment and design the reinforcement details. Okay, that is the basic condition for designing of the beam and taken the reinforcement detail. Now understand. You take the continuous beam means you take the 3 conditions. That is the main reinforcement detailing. The compression zone is a first end. This is A is a compression will be high in moment. Tension is 0. So provide the minimum. The tension is high. So I provide the tension reinforcement. It is low. And this is a CC. Then he provided the compression and tension. The tension is 0. Compression is high. So I provided the top zone. This is our neutral axis. Now understand. how to take the cross sections, how to provide reinforcement details. This is the same procedure as a STAAD Pro will be given the result also. It's okay. I give some points. This is a column. Yesterday we'll discuss about this type of columns. This is another one is a bundle bars. As per bundle bars, the construction reinforcement. The more number of bars will become used for bundle bars. You have bundle with 2 bars. This the design is in SP10 for how many spacing will be provided for the bundle bars and others provided in SP34 port rules. Okay. Now understand how to provide the bundle bars and others. Sorry, next one. Beams. The positioning of beams is some conditions. So next one, categories of beams. How to categorize in your beams in your building? Column have some axial, biaxial, uniaxial. Beams have depend upon your end condition. What is the simply supported beam or continuous beam, or one end is fixed, other end is continuous or fixed end. That is the first condition for designing of the beam end condition. Sometimes you will be simply supported beam in your building. The one end is fixed, other end is free. The different types of beams are in your building. So the first categorization is the end condition. The next one is a span. Different types of span. So one beam is a 7 meter, one beam is a 4 meter, another one is a 8 meter. That is the second condition. Next one is a load type. Depend upon your load, a point load or UDL load, linear bearing load. That is a different types of load condition to the category. Next one is a section type. Section type is a rectangular beam or T-beam. That is a 2 types of beam. That is the main condition for categorization of the beams. Okay, that is the end condition. I will tell about. Beams are simply supported at both ends are UDL. That is one condition. Beams are simply supported one end are fixed, another end is continuous. Beams are continuous at both ends are UDL. The miscellaneous beams. Okay, this is a different condition to calculate the beams in your building. The next one is some conditions. Okay. This is a checking for miscellaneous beam using for moment distribution sums in your structural analysis. Already you studied the structural analysis. You calculate the moment distribution. I check the STAAD Pro manual. It will be correct. The moment distribution method for sums. I already told the minimum reinforcement for tension zone and the compression zone as per IS 456. We provided the minimum reinforcement for compression zone, this formula, and a maximum reinforcement, this formula, compression zone also, this formula. When you provided the side reinforcement for your beams, okay, so your beam depth is more than 750 mm, will provide at the side reinforcement. Okay, the only the beam will be provided at the top and bottom, compression zone and tension zone. When you provide the side reinforcement, your beam will be excess on 750 mm, will be provided the side reinforcement. Minimum 750 mm do not provide the side reinforcement. You go for maximum reinforcement 750 mm, you provide the side reinforcement also. That is some conditions. Another one PPT is there. I missed the PPT. I will take at the end of the class. I will send you that PPT. This is our condition. What is under reinforced to over reinforced? There is a shear. How to shear will be forms. This is the shear cracks will be forms in your building. This 1/3 of the columns to beam. Okay. This is the shear cracks is formed in opposite direction to provide the different types of inclined balls, bent up bars, and shear bars. The beams are provided for stirrups, right? The beams are provided for stirrups. You will watch it in building or anyone. The center of the beam will be stirrups will be high, 200 mm or 210 mm or any. But the end condition to provide the less spacing. 130 mm or 140 mm for less spacing for stirrups in beams. Why? The same. The shear cracks will be formed in these corners. So the stirrup spacing will be less. Automatically the shear will be arrested. So it will be provided for the mid of the portion. Shear will be 0. So the stirrup spacing will be high. The two corners, the stirrup spacing will be less. The shear will be high. So your stirrup spacing will be less. arrest the shear cracks. That is the main concept for shears. You studied in MO mechanics of solid. Shear force diagram, bending moment. This is the same concept. Understand what is in the shear force and bending moment. This is same. Already I told that in paint. That is our beam reinforcement. Compression zone will be provided the extra reinforcement. In this section area, tension will be minimum bar. Center is a tension zone is high, so provided the additional reinforcement, compression is the minimum, and the same as the end condition. The minimum reinforcement will be provided, tension will be high. That is the condition. So, okay, these are the small concept for beams. How to take the reinforcement details, what are the conditions will be there. Next, what are the types of beams using in our field? The mainly what are the beams? The first one is a secondary beam. Okay. The next one is the secondary beam. The secondary beam is mainly connected with beam to main beam or column to main beam. That is called secondary beam. The secondary beams you will be calculated. The moments will be released. I tell after how to release the moments for secondary beam. Okay. How to release the moments. This is the secondary beams using for joining for beam to main beam and column to beam is provided for the secondary beam. The next one is a secondary beam. Next one is the hidden beam. The hidden beam is mainly provided for bottom of the slab. The hidden beam is mainly provided for the bottom of the slab. The large slab is there. Large slab is provided. The deflection will become. So the thickness also, slab thickness will be high. If provided the large thickness of the slab, the thickness will be high, something deflection will be taken, short-term deflection and long-term deflection. If provided this type of hidden bars, it will resist some force. But any space of any pages in IS 456 not provided in hidden beams for codes. Okay. Is only doing in construction work sometimes only. It's not provided. Hidden beams topic is not provided in IS code books. Okay. Some of the companies are using these hidden beams to reduce the slab size and reduce the deflection size, etc. This is mainly using for slab purpose. This is the hidden beam. This is a cross section. This beam will be provided for 930 mm is the width, but depth is less than slab. That is the hidden beam. The cross section, the maximum depth is provided in slab. Next one is the inverted beams. See this beam is downward to slab, right? This is our slab. The beam will be below the slab. This is slab is there, but above the slab. Why? These are called inverted beams. Okay, these are all one type of inverted beams. The inverted beams are provided for architecture purpose. The maximum, the inverted beams, same like a normal beam, it will be provided for top of the roof. The name is called inverted beam. Same procedure to design this beam, simply provided the top of the roof. The name is called inverted beam. You provide the architecture purpose. You take the hall for 20 feet by 20 feet. You fix the inside the hall in this beam. It will be not clear or something will be there. So you take it to top of your slab for architecture purpose. That is called inverted beam series. One of the finished building. This beam is under the top of the slab. This is called inverted beams. This are using in our field also. For maximum, the inverted beam using for elevation purpose. This area is a hall is there. You downward the hall for this beam, it will be elevation will be something or any spaces will be less. So you provided for the top of the slab. This is called inverted beam. The most of the buildings will be using. This is also same like this field picture. See this is our compression zone, tension zone, compression zone. Automatically provided the extra bars for our compression zone, the same tension bars for our mid, same compression. See this. This is our secondary beam. This is our main beam. This is our compression zone. This is provided for top of the additional bars. This is also bottom zone. Tension will be high. So provided the additional bars for tension zones. There is a deep beam. The deep beam is provided in IS 456. The maximum the deep beams provided for in bridges. This type of deep beams provided in bridges. Okay, this is a simple concept for designing of reinforcement for beams. There are different types of beams in our field. Okay, this is the I already told that bundle bars. This is the design procedure for bundle bar. As per ST34, you refer that how to design the bundle bars and others, etc. This is how to provide the detailing diagram for your beam. Okay, singly reinforced beam or doubly reinforced beam. You refer the SP34 code book. It's provided all the reinforcement detailing, etc. Okay, now understand that is a simple concept for your beam concept. Okay, then I go for slab. Yesterday I will discuss about how to take the bending moment and shear force reaction value. I simply go to bending moment, then go to I take the combination load. See this automatically. This is value is high, the mid is in tension. This is the high in compression zone. Simply go to geometry. Sorry, go to post processing. Okay, then go to bending. Is automatically result view value beam result end midpoint and end point. See this value. This is 11 kilonewton, 10 kilonewton. This also you take the your beam is designed under the moment condition. This is a 10 automatically mu equal to you provide the mu is a 10. You will be automatically you will calculate the design formulas. Okay, now understand. Same procedure will follow on STAAD also. Okay, shear also. See the shear force. Shear is mid portion. The shear will be 0. Why? This corner and this corner shear will be high. Why the shear cracks forms in 1/3 of the beam in this corner. So we provided the type of shear cracks. How to provide the shear reinforcement and others. The next one is the reactions. This reaction is a load total. Okay, the total loads transfer to column for your building. That is called reaction load. The slab transfer to beam, the beam transfer to column, the totally the column load transfer to footing. This is our column load. This is automatically. This is our. This is see this difference. This is the column beam load will be this beam is half load transfer to this columns. So 67. But this beam, this half beam will this transfer to this column. This half beam will be transferred to this column. So this beam will load will be high. Same procedure. See this. This half of the beam and this half of the beam. So this half, the load will be high. This corner, this half of the beam only transfer to column. So load will be less. That is the main condition for your beam design. The next one, this is our deflection. Deflection for your beam. The span by depth ratio provided the deflection check for your formulas. Okay. You provided the model post processing shear force analyze part is over. The next part is a design part. Okay. Design part is a two types of design part. I tell about first part, design part. Simply go to modeling, go to design, you go to concrete design. Okay, simply go to concrete design, then go to our current code. Our current is IS 456. Okay, IS 456. Our grade concrete. Go to general design concrete. Select the IS 456. That is a code. Next, how to apply the materials for this your beams, a grade of concrete and a grade of steel. Then analyze in your beam and columns. Okay. Then how to apply the materials for your beam and column for your building. Simply go to select parameters. Simply go to select parameters. Is the all the parameters are there. This side will be taken into this side. First of all, taken into this side. Then go to. I take only three things. I taken into only three things. First one, I take the strength of the concrete, compressive strength of the concrete, then yield strength of main reinforcement and shear reinforcement. I taken unto three only. The first one is the compressive strength of concrete, second shear main reinforcement, second one is a shear reinforcement. Then how to add the values, our grade of concrete and grade of steels, etc. Then simply OK. Then go to define parameters. This is our grade of concrete M25. This is a kilonewton per meter. It's a confused means is changed into Newton per mm square. Any confusion? How to change the unit? Simply go to tools, go to set current input units, mm Newton. Click OK. Automatically units change into Newton per mm. Simply go to exchange the 25, add main reinforcement 415, add secondary 415, add, close it. This is I get the grade of concrete and a grade of steel. I apply for the beam and column for all the things for FE25 and FE415 and others. Simply click this F25, assign to view, assign yes. Next one, assign to view, assign yes. Next one, assign to view, assign yes. I apply the three conditions. The next condition is the designing of beams. How to design the beams? Simply go to commands. Okay. Simply go to commands, go to design beam. Select the design beam, then add. Next one, design column. The next one is a takeoff. The takeoff is the total quantity of your concrete and the total weight of your rebar. That is called takeoff. I simply click this takeoff, add. I select this designing beam and designing column. How to apply the designing beam? Go to select option, beam parallel to X. Then go to assign to selected beams, assign yes. Assign yes. The next one is the Y direction, designing of columns. Simply select this columns, then select beam parallel to Y direction. Select, then go to assign to selected beams, assign yes. I simply selected this beam. Then go to design the beam and the column. Go to analyze, run analyze, save. Then zero warning, zero error, zero no. There is no problem. Then check the reinforcement detailing for your beam and columns. Okay. How to check the beam and columns for this reinforcement detail? Simply click this two option is there. Directly go to the result option. And another one is here, right on your column or beam. Okay. Right click on your column or beam. I simply go to select, double click, then go to my concrete design. Simply select this. This is the value for concrete design. First one, our grade. This is our steel grade of rebar. This is the concrete. This is the AST required. This is the AST percentage number of bars. There is a moment acting on this beam. Why? This is only one moment. This beam moment only acting. So this beam will be 0. That is the condition. This beam will be 0. How to check the AST value is correct or wrong? Simply go to as per IS 456. You refer the IS456. There is some points. The first point is the cross section of longitudinal steel percentage not less than 0.8, minimum 8%, not more than 6%. That is the first condition, AST value. Not less than 8% or more than 6% for PS bridges. But our column is a 4% is a maximum. For economical, you provided for 2% only. For economical, you provided for 2%. The normal accepted limited is 4%. The 6% for PS. The minimum is a 0.8%. But our AST values minimum will be 0.65. You provided you taken into additional value, you take converted into 0.85. Okay, this is the first step. Number of rebars. As per IS456, the minimum number of rebars. The 4 numbers rebars minimum for rectangular and 6 for circular section. The bars, the rebars not less than 12 mm. The minimum size of the rebars reinforcement in column and beam is 12 mm. The spacing is helical reinforcement, minimum is 6 bars. The spacing not exceed 300 mm for tie facing. The long bars is not spaced more than 75 mm either. I will show that picture. The corner size provided the higher dia bars. The column is there. The 8 bars are there. 4 bars are 16, 4 bars are 12. The corners will be provided the 16. The internal will be provided the 12 bars. That is a small condition for this column as per IS456. You refer the code book. This condition are there. It's a minimum 0.8%, 6%. This a column is okay. You change into 0.8%. I select this next column. This is the moment value. This is a 0.85. This is also check this. This is the same like that. Another one. This is the load also. PU. The PU means load. The load acting on this beam. The next one, center column. Simply select this. This is also same conditions. Okay, but load will be high. The moment will be less. Why the moment will be less? The moment will be transferred to 2 directions. This automatically the moment will be transferred to this direction. Automatically the moment will be less. You already studied in structural analysis the moment distribution method, the same concept. Why the moment will be high in this area? The moment will be transferred to this one. Opposite, no beams are there. But this column, this beam moment transfer to this side, this beam moment transfer to this side. So no moment is there, something moment 0.11. This load is 130, 125 and AST and bars. The next one, same procedure, this one. Next is this column, select this. This is also same, our moment and then load, AST percentage, bars and others, etc. This is a corner column. Its moment is 1.2. Load will be less. This is also same. Now understand how to apply the values. Then how to see the beam values. Simply double click this concrete design. This is some difficult to see this value. How to see this? This is a longitudinal section. This is the cross section. How to see the values in easy method? Simply go to analyze. Then go to view output file. Then concrete design. Okay. This is our beam design. The section, our section is a length and our size, beam size and a cover, the minimum bar and maximum bar, the grade of concrete. This is our top reinforcement, bottom reinforcement. See this. This is the top will be high in compression zone, the mid will be and this top. And this is also reinforcement also provided. Provided 2 12 bars and 2 also it provided the 2 10s. This is stirrups. They are simply common to all the things. See this, the beam details. The compression will be high, tension is high. Then simply scroll this. These are the beam details. The bottom, this is our column details. required steel area, required concrete area, the mill. 4 numbers of bars will be provided, tie bars. All the details moments will be provided in this areas. Okay. Now understand how to see the values and others. This is the minimum values is there. How do I give the some additional loads? Simply go to loads, go to I change units, tools, set current input units, meter, kilonewton, okay. Then go to loads, I take some loads, simply go to add, I give some high loads for all the beams. Then go to member load, uniform force, I give minus 30 for all the beams. Yes, close. Simply select this, go to select beam parallel to X direction. Then go to assign to selected beams, assign yes. Then go to analyze, run analyze. I will change my loads in extra loads. Then see the bending moment for your building. Then go to post processing. Okay, combination load only. Then go to bending moment. See this, the load will be high. The automatically or bending moment will be based on your load condition. Simply go to view value, beam result, mid and end span. Note. See this moment is 47. This moment is 34. This moment is 64. See, these 3 different moments are there to take the 3 cross sections. The reinforcement will be designed on this cross section only. This is a 40. This is a 66. This moment is a 70. High in this moment. Then go to design your beams. Once you design, no problem. Go to design. Simply click this column. Concrete design. Now this design will be same procedure. Concrete design. This AST is high. 263. The load also high. This is 407. The value is 15.39. Now understand automatically all the values will be increased. This one says this AST percentage is 1.82. So load will be high. This column will be load acting 833. This the moment will be less, so beam will transfer this AST percentage. The 4 numbers of 20 mm bars will be provided. This also same. This is automatically the load is 800 kilonewton. This is a moment. This is our required and 4 numbers of 20 mm bars. Then go to concrete design, same like that. Then see the reinforcement detailing for beams. Now understand, you increase the load, automatically the beam moment and all of this will be increased. Then go to view output file, done. Then go to concrete design, see this. This is our top bar, compression zone 864. Then our middle will be high. Then end of the compression zone will be high. How to take the cross section? Say 8, I take this beam, okay? I take this beam. Yeah, same condition. See this is our beam, 844. This is a minimum bar, this is a maximum bar. This is a 3 cross section, that is a beam. See, same procedure. This is the moment is same procedure for this beam. Fixed end condition. There are 3 cross sections. This end is a top reinforcement is high. So provided the top reinforcement. See this, I provided the 4 reinforcement. This is a minimum bar. So, okay. The next one is the tension zone. This will be high. So I provided the tension zone. I provided this is the 4 bars or 3 bars. This is only any 2 bars. Then this one. that 10. The 10 will be 981. Is a bar will be high. This is small. So simply go to this bar will be high. So it's provided the 4 bars. This is the 2 bars. Simply go to see this automatically. This is a 25 mm 2 bars for full length. This is the 2 bars, 2 bars. This is the 7 bars for 10 mm dia. See this difference for your reinforcement. This is a designing result. This is a two-legged. See this automatically 190, 190, 190 mm based on this condition. The next one, this one on and 883, same procedure will be taken the reinforcement also. This is the shear calculation. This is automatically it will be calculated. Understand how to calculate the beam reinforcement and column reinforcement. Column also provided is a short column or long column. The column grade, column reinforcement, and the secondary column length and the cross section. Say end joint, this is short column or long column, required steel area, required concrete area. Main reinforcement will be provided. Then equally distributed the tie reinforcement 190 mm spacing. This is a load and the moment will be acting on your column. Okay, this is the details for your columns. The next one, takeoff. This takeoff is a concrete quantity takeoff. This is the total building is a 4.4 meter cube for my column, and in beam total 4,909 Newton for weight for my steel. 10 mm dia bars, 12, 16, 20, 25. It will be used. Now understand how to see the results, beams and columns for the STAAD. This is the main condition. To take the 3 cross section, this is a column is simply click this. This is a reinforcement 12 mm bar 4 will be provided. This column it will be provided 4 numbers of 20 mm bars. Next floor is a 4 mm 12 one. You'll reduce the rebar sizes, no problem. You'll reduce the rebar sizes or column sizes also. You'll be reduce them. The first floor is a provide the 4 numbers of 20, but you provide the next floor is a 4 numbers of 12 only. So you reduce the first floor, you provided the 4 numbers of 20. Next 3 floors, you reduce the 4 numbers of 12. No problem. You'll be reduce the rebar sides. You will be design the economical also. So you will check the all the column values, all the floors. This is the 420. And check this floor. 412. This is all of us 412. Then provided this column only 4 bars, 4 number of 20 mm dia. This 3 also you provided the 4 numbers of 12 mm bars. You reduce the sizes also, rebar sizes and concrete sizes. Okay. Now understand how to create the 2D model and pros causing bending moment and shear force. How to see the shear force values and reinforcement values, beam design and column design, etc. Okay, now understand that is a basic concept for designing of our 2D structure. Okay, now understand how to see the concrete values, how to take the cross sections and the columns, how to see the column values, others, etc. Now is design the 3D framed structures. Okay. Now I design one 3D framed structure. I simply take one box. This is our plan. I take a square also. That is one easy one. This is separated into. Okay. This is a center to center is a 3 meter. This is a 4 meter. This is a 5 meter. Okay, this is a 3 meter, 4 meter, 5 meter. This height is a width is a 3 meter, 4 meter, 4 meter. This is a G plus 4. Okay, today we will create the same model G plus 4. This is the length. This is the x-axis. The x-axis is the 3 bay is there. One bay is 3 meter. Another bay is 4 meter. Another bay is 5 meter. The width portion also 3 bays. One is a 3 meter, another one is a 4 meter, another one is a 4 meter. So, okay. And the floors, G plus 4 floors are there. How to create the 3D models? Okay. Then how to create the same one? Go to STAAD. Simply close that. Simply go to open the new project. Same. I am coming on first. Simply go to new project space. You change the any project name. Newton, kilonewton. Next, finish. Okay. Simply finish this. Then go to how to create the same plan in STAAD Pro. This is 3 meter, 4 meter, 5 meter. Okay. Simply go to STAAD. I'm going to geometry node method, snap node method. Our first point, you go to any building. This is the yesterday we will tell that this is the axis 0, this is the plus, this is a minus, this is the plus, this is a minus. You go to backward, you put the minus, then you come to left side, you will be at minus, this side will be plus, and this side also plus. Okay, that is a graphical condition. Okay, our first point. Our first point is a starting point. Three axes are there. 0, 0, 0. I tell about how to give the heights and others. Our first point is a 0, 0, 0. The next point. First point. This is the first point. This is the first point. Second point. Third point. Fourth column. Fifth column. Sixth. Seventh. Eighth. 9, 10, 11, 12, 13, 14, 15, 16. 16 column is there. How to create the 16 node points? Okay. How to create the 16 node points in STAAD? The first point is a 0, 0, 0. This point. The second point is a this to this distance. 3, 0, 0. Next is this point, third point. Third point is this total distance 3 plus 4, 7. 7, y also 0, z also 0. Next fourth point. Fourth point is this point. That is the total distance 3 plus 4 plus 5, 9, 12. 12, 0, 0. Okay, next one is the fifth point. This point. The x is 0, y also 0. But z is a this direction is a z right. This is the z direction. So z distance is a 3 meter. Z is a 3 meter. Then go to sixth point. Sixth point, x distance is a 3 meter. This point, x distance is a 3 meter, y also 0, z is a 3. This backside distance. Next is seventh one. Seventh point is at this point. X is a 3 plus 4, 7. 0 is a this distance is a 3 meter. Next one is a eighth point. Eighth point is at this point. X is a 3 plus 4, 7. 7 plus 12. 12, 0, Z is a 3. 3. Next one is a ninth point. The ninth point is this point. X also 0, Y also 0, but Z is a 3 plus 4. This distance, this 2, this distance. Distance is 4, this distance is a 3. Automatically 3 plus 4 is a 7. The next point, 10th point. The 10th point is this point. X is a 3, Y is a 0, Z is a 7. Next 11th point. 11th point is at this point. Simply go to this distance 7, 0, this to this 7. Next is a 12th point. 12th point is a last point. 3 plus 4, 7, 12. 12 comma 0 comma 7. Finish. Next one is a 13th point. This point. X is a 0. Then is y also 0. Z is a 3 plus 4 plus 4. 8, 11. Understand? This total distance 4 plus 4, 8 plus 3, 11. Next 14th point. The 14th point is a, this to this distance is a 3 meter 0. Z is a total distance. So we provide the 11. Next 15th one. 15th point. This point. Total distance is a 4 plus 3. 7. X distance is a 7. 0. Z distance is a 11. Next one. 16th point. Last point. X is a 3 plus 4 plus 7 plus 5. 12. Y is a 0. And the total distance is a 4 plus 4, 8, 11. Now understand. This is a method to create the any symmetrical, unsymmetrical node points for your buildings. Okay, this is a basic concept. This node point I directly type in my tab. Okay, go to geometry node. The first point is a 0. The second point is a 3. Next one is a 4. Total is 7. Next one is a 12. Next one is starting is a 0. The Z is a 3. To distance is a 3 point. Third point. I simply enter 3. Next one is a 3. Z is a 3. 7. 3. Then 12. 3. Next point is a 0. But Z is a this to this distance. 4 plus 3, 7. This point 4 plus 3, 7. Simply enter 7. The next point is a 3, 7. Next one is a 7, 7, 12, 7. The next point is a 0. Z is a total distance 11. 4 plus 4, 3. Totally 11. Simply enter 11. The next point is a 3, 11, 7, 11, and 12, 11. I simply created the X is Z coordinate and series. Automatically it's created the X is Z coordination. I need 16 node points. Right click, go to labels, node numbers, apply, OK. My node number is 16 numbers. I simply created the X is the direction. I simply created X. Then next front view. This is our building. This is our front view. Right. So front view 1, 2. Yeah, 4 base. This is our fixed support. This is our 4 base. Right. 4 base. This distance is a 3 meter, 4 meter, and 5 meter. The first ground floor to our ground floor height is a 4 meter. Next floor is a 3 meter. The another floor also 3 meter. Another floor also 3 meter. Another floor also 3 meter. The first floor, why the height is high? Simple. For example, this is a ground level. Okay. For example, this is a ground level. This is the ground level 2. This is our basement level. Okay. This is our ground level. Okay. This is our basement level. Okay. The column will be comes on ground level. This is a ground level. This is a below ground level. This is a below ground level. The column go to this below. This is a footing in this below ground level. So below the ground level distance 1 meter. So okay, below you calculated the depth of the footing also below the ground. That is a below the ground is 1 meter. This is a 3 meter. Totally, my height is a 4 meter. Sorry, This is a 1 meter means the basement is also 0.2 meter or something. Totally our building height is 3 meter. Totally 4.2 meters. Or below the depth of footing is below the ground level is 1 meter. Our basement height is a 0.2 meter. Our ground floor is a 3 meter. Totally 0.2 meters. Okay. Simple procedure. This is our I take into 3 layers. Okay. This is the ground level. This is the basement level. This is the ground floor roof slab. Okay. This is the below ground level. Below ground. This is the footing will be started. This is our pedestal, right? For AISSMS, this is our pedestal, right? The column will be starting on this. Okay. Go to the ground floor. Column will be starting on this. This is our basement to ground floor roof level is a 3 meter. Then basement to ground level. The basement to ground level I take a 1 meter. Then ground level to below the ground pedestal height is a 1 meter. Totally my height of the column is 4 meter. That is the concept. You created the any building, the ground floor height will be increased with other floors. So that is the concept. You calculated the basement height and depth of the footing, added the ground floor height also. This is our ground floor area. This is our basement. This is our gravel ground floor below. It totally 1 plus 1 plus is a totally 5 meter. That is a concept. How to increase the size in easy method? First of all, simply select the node cursor. Simply select the node cursor. I select the all the nodes. Then go to geometry, translation, repeat. Then go to y direction. Y is the height. It's a 5 meter. I need a ground floor with a 5 meter. Only one step. Link steps. Give OK. Now it's created. Then join this beams. Go to geometry, add beam from point to point. Simply join this all the beams. Provided the ground beams also. In I provided the 4 feet, 4 meters. I provided the ground feet also. We provided the ground beam also. 1 meter or any meter. Currently join this node points. Yeah, that is it. Currently join the node points. Yeah. It's okay. For example, I will create this is a one-way slab, this is a square slab, this is a rectangular for your difference. How to apply the different slabs loads. This is a one-way slab. I apply this is a one-way slab. This is a rectangular slab. This is a square slab. Okay. Now I created the ground floor. Then how to create the G plus 3 floors? Once you same level, you select the full of the building, but we are different level for the height. Only select the top of the X and Z direction. How to select the X and Z direction? Go to select option. Go to beam parallel to X Z. That is an easy one. Sorry. Select beam parallel to X Z. Okay. Otherwise, you go to beam parallel to X, then select beam parallel to Z. Okay, this option. Then I need a 3 floors or 4 floors. Geometry, go to translation, repeat. Other floors I have 3 meters only. Simply go to I need a 4 floors. Simply click this, then link steps. Give OK. This automatically it will be created the G plus 4. G 1, 2, 3, 4. Other this is the ground floor only for 5 meters. Then other floors will be same 3 meters. Provided the This is our basement level. It's a ground level. I provided the ground level for my grade beam. You provided also ground level for this grade beam also. No problem. I provided this 1 meter and I provided grade beam also in ground level. This is the concept for creating the 3D model. Any building you will be simply created this type of model. You provide the X and Z direction, then go to translation repeat. You simply created the buildings. Okay. And check the dimensions also. Check the dimensions. First of all, go to labels, node numbers, apply and hide this. Go to tools, dimension beams, display. Okay, check the dimensions. This is also 5 meter, 3 meter. This is also already 3 meter, 4 meter, and 5 meter. You check this. This is correct. Simply go to tools, dimension beams, remove. Okay. Now it's the first step. Modeling step is over. I simply created the 3D model for in STAAD. Next step was same process. The next step was same process. Go to modeling. General load will be different, but other steps are same. Simply go to general. Simply go to general, material, concrete, assign to view. All the material are assigned to view. Then go to property. You go to one building, it's have a 5 or 6 type of column sizes, 5 to 6 type of beam sizes and slab sizes will come. You go for, you provided the only one beam sizes and only one column sizes for whole buildings, it's totally wrong. It's okay. You will be change the beam sizes and column sizes. Yesterday will someone ask the doubt how to orientation of the columns. Today will be tell. It's okay. First of all, I take a trial section. Go to define. Go to rectangular. 0.23 into column size 0.45. Add then beam size 0.38. Add. I take the beam size is 0.230 into 450 and 230 into 380 for my beam. I select this column, select beam parallel to y direction. Assign yes. Then beam, select beam parallel to z direction. Select beam parallel to x direction. Then assign yes. Then right click, go to 3D. See this, our column depth. Our condition is column depth position to longer span side. See, this is the longer span side, but the column orientation is this side. How to change the orientation? This beam. Take this any beam. This is our beam. How to change the orientation for this beam? Simple method. Simply go to define orientation, but same size, opposite size, 0.45, 0.23. I enter this 0.45 and 23. Add. I change this orientation for this columns. This column. Simply select this. Or other option is that there is a cut section. You cut the section also. I cut this section. How to cut this section? Simply go to tools. Go to cut section. That is a main option for cut the any floors, any level areas to using the cut sections. This is a range and you cut the section by joint. Before you cut the section, you will be apply the node points. Right click, labels, node numbers. Apply OK. I cut this section. I change this orientation for this column. Simply go to select tools, cut section. This axis, this is the x direction, this is a y direction. This is a x, this is a y, this is a x plane, y plane. My node point is 29. Okay, I cut this section. Simply go to property, this size. I will be change this column size. Simply select that. Go to assign yes. Automatically change into orientation. Simply go to tools, cut section, show all. Then go to right click 3D. See this column orientation. This column only oriented to longer span side. That's the orientation. You change in the column size, automatically change into orientation. I need change this all into this orientation. It will change into breadth or width size automatically. The column orientation will be occur. This is the simple steps to change the orientation of columns. Will we change the all the orientation of the columns? This is the second steps. The next step is the support. Support, simply go to create, fixed, add. You go to this is the isometric views. You go to 2D structure, you apply the support is easy, but 3D structure is some difficult to apply the select the node. So simply go to view from is plus is the direction. Easy to apply the supports view from Z. Simply click this view from Z direction. Go to select the bottom nodes, then go to assign yes. Then go to 3D view. This automatically it's create the support for this bottom area. Same procedure. Yesterday we'll discuss about general. I apply the materials, property, then supports. Then next one is a load and definition. This is the some difference to apply the three types of slabs. One is a one-way slab, two-way slab, a one-way continuous are there. I tell about something. Yeah, that PPT is it's okay. Okay. This is some of the conditions are there. There is a slab condition. That is generally economically two-way slab only compared with both ends, one-way slab. There is some conditions will be. So next one is a different conditions for your slab conditions. This is a simply supported slab, simply same as a beam, simply supported at one end and continues at other end. Slab continues at both ends and miscellaneous type. Two-way slab, slab with corner restrained, slab with corner not restrained. You separated into different types of slabs in your buildings. Okay. This is some percentage for steel, percentage for your columns, beams, and others, etc. This is the minimum reinforcement for as per IS 456 for slabs. This is the main condition. How to load separated into one-way slab and two-way slab based on your yield line theory. Okay, the maximum the one-way slab will be the moment transfer to shorter direction, but the transfer to load transfer in longer side beams. Okay, moment transfer to this distribution transfer to load in longer span in one-way direct one slab. So the four beams are there. You provided the heavy in two longer span beams. You provided the heavy beams. These two beams are provided for smaller size. That is a one-way slab. The one-way slab is provided for longer span side only. The one-way slab load will be taken. The shorter span will be not taken the load, but moment will be taken the shorter span side. The two-way slabs are the four sides are load will be taken. This is the triangle portion, trapezoidal portion, triangular portion. The two-way slabs are four sides of load will be taken. That is the different condition for one-way slab and two-way slab. That is the minimum sizes, recommended sizes for slabs. There is a field view. Some of these two-way slabs is there. That is a one-way slab. This one-way slab is load distributed into only two sides. See this one-way slabs load distributed into two sides. That is the two-way slab. The two-way slabs are distributed into four sides. There is a hidden beam. Already show the beams. This is a real picture. The hidden beams are provided in the slabs. This is the hidden beams. This is the main beams. The two-way slabs are four sides of stand. This is also one-way slab. This is the two sides of load will be transferred. Okay. This is also two-way slab. This is a two-way slab. Detailed drawing for this two-way slab as per ST34. This is a two-way slab. This is a one-way slab. Sorry. Yeah, that is a one-way slab. It is a two-way slab for detailing for reinforcement. Okay. This is a small condition. So many conditions are there. This is a small conditions for detailing for your structure. Okay. Then the load condition. Next one is the load conditions for your buildings. Okay. Same procedure. Simply go to load case details, add, then go to first one is a dead load, add, next one is a live load, add. Okay. What are the loads will be calculated? Dead load is automatically it's taken as a self-weight. Simply click this add, go to self-weight, add, close, self-weight, assign to view, assign yes. Automatically self will be taken. Automatically self-weight will be taken. The next one is a load case 2. The load case 2 is a member load. The load case 2 is a member load. Simply go to load case 2, add. Member load is a big load. Is based on its conversion as per IS 87 part 2. I simply click this 14 kilonewton. The is not commonly for all the floors. It differs from this another floors based on the height condition. Top of the floors will be differ. The middle of the floors will be preferred. The staircase area will be load will be differ. But I apply for this all the load condition. Simply click this. Go to select beam parallel to X direction. Select beam parallel to Z direction. Then assign to selected beams. Assign yes. I apply the brick load for this all the load. But the brick loads are not common to all the floors. It's differ from the floors. The staircase area will be differs. Will be differ the load areas. Okay. Now understand. The next one is the floor loads. The floor loads are separated into one-way slab and a two-way slab and square slabs. Okay, some of the groupings and other etc. Now once I complete this section now itself, tomorrow will be discuss on how to apply this, some time to be taken, how to apply the one-way slab loads, two-way slab loads and others etc. Then see the earthquake load also. Okay, today we'll discuss on 3D. Tomorrow we'll discuss on how to apply the one-way slab and different and two-way, how to groupings, how to analyze these floor loads and other loads, how to take the concrete designs and others etc. Will earthquake loads. So okay, so okay. Today now I complete this and now any doubt will ask me directly. Tomorrow we'll discuss on slabs, how to apply the slab loads and others, earthquake load in static only. Tomorrow we'll discuss not dynamic. The dynamic will be taken the too much time and too much difficult to handle it. Tomorrow we'll discuss on static only. That is the easy one. Okay.
Okay, thank you so much, sir. Anyone from the audience, if you have any doubt or any questions, please just raise your hands. We will unmute you and then you can ask your question to the sir. If anyone has any question, please just raise your hand and we'll unmute you.
AISSMS. So I guess there are no more questions. You can please put your questions in the chat box if you have, or if you have any questions, you can also ask so tomorrow. So we are at the end of the session today. I express my heartfelt gratitude to our sir, Uday Shankar, for his wonderful and indeed very informative session. We have bloomed our interest in this topic. We look forward towards our next session, which will be held tomorrow at the same time. The feedback and attendance link for today's session is shared in the chat box. I request audience to give the feedback and attendance. Also, tomorrow's session is on the topic earthquake and wind analysis in frame structures. All the participants are requested to join the same link of Zoom meetings tomorrow at 2:30 p.m. sharp. Thank you everyone for joining in. I also thank you, sir, for giving us your precious time.
Thank you.
Thank you so much, sir. Yeah.
Thank you, sir.